See this problem. A long solenoid with 15 turns per centimeter has a small loop of area 2 centimeter square placed inside the solenoid normal to its axis. If the current carried by the solenoid changes steadily from 2 amperes to 4 amperes in 0.1 second, what is the induced EMF in the loop while the current is changing? Our motive is, we have a solenoid like this, and it is the axis of the solenoid. So normal to this solenoid, and inside the solenoid we are keeping a loop which is having area A, and the solenoid has the turn density N, and we are sending a current I1 inside it, and we are changing that current from I1 to I2 within a time t. Due to this change in current, there is a change in flux passing through this solenoid and as well as this loop also. Whenever a change in flux experienced by this loop happens, there exists some EMF in the loop. So we need to find out that EMF. That is our motive. Now come to the investigation part. First current I1 is equal to 2 amperes and second current I2 is equal to 4 amperes, and the time taken to change t is equal to 0.1 second, and the area of the loop A is equal to 2 centimeter square, that is equal to 2 into 10 to the power of minus 4 meter square. We need to find out this EMF. Now come to the resolving part. We know that the magnetic field in a solenoid is equal to mu naught N into I, where N is the turns density and mu naught is the medium constant and I is the current passing through it. But we are changing the current from I1 to I2. So the change in magnetic field dB by dt is equal to mu naught into N into I1 minus I2 by t. So change in current by time. That is equal to mu naught is the medium constant. The value of that one is 4 pi into 10 to the power of minus 7. And N is the turns density, which is 15 turns per centimeter. So if we convert into SI unit, it will get 1500 turns per meter into I1 minus I2, that is minus 2 divided by t is 0.1 second. That is equal to minus 4 pi into 10 to the power of minus 7 into, here you have 0.1 second, so that is 1 by 10. If this 10 goes up and multiplied with this one, you will get 15,000, and when that 15,000 multiplied with this 2, you will get 30,000. So that 30,000 can be written as 3 into 10 to the power of 4. So on a whole you can write minus 12 pi to 10 to the power of minus 3 Tesla per second. Now we will find the EMF generated in the loop, that is equal to minus d phi b by dt. Phi b is the flux passing through that coil. It depends upon the magnetic field that varying in the solenoid, which can be written precisely as minus N into A into dB by dt, where N is the number of turns in the coil, and in this case we have only one turn, so this can be taken out, and A is the area of the coil and dB by dt is the change in magnetic field. Now I want to substitute the given values. Minus 2 into 10 to the power of minus 4 into minus 12 pi into 10 to the power of minus 3. That is equal to minus minus gets cancelled, so 2 12s 24 pi into 10 to the power of minus 7, or in precise I can write 7.51 into 10 to the power of minus 6 volts. So this much EMF is generated in the coil.